Hi, I'm Rob Tweed, the developer behind the QEWD platform and QEWD-JSdb, and in this second video on QEWD-JSdb I'll give you a quick view of it in action. If you haven't already watched my first video showing you how to install and configure QEWD-JSdb, I'd recommend you do so first. I've added the link in the comments for this YouTube video below, or if you subscribe to my channel you should be able to find it. Just a reminder then, in the previous video I'd installed the QEWD-JSdb repository on my Raspberry Pi 4, configured the Dockerized QEWD service to listen on port 3000, and I'd started it up. So in this video I'll carry on from where I left off. As in the first video, although I'm using a Raspberry Pi for this screencast, everything I'll show you will work identically on any Linux platform. So in this second video, I want to show you how you can begin to play around with and explore QEWD-JSdb from within the Node.js REPL. To help understand what you'll see, I'm going to go to my browser. Here's the QEWD monitor application that I'd started up in the first video, and I'll open a new tab and start another application, one that's included with the QEWD-JSdb showcase and known as the viewer application. As you can see, this doesn't show much yet, but you'll see it automatically burst into life in a few minutes, and then I'll explain what this viewer application is all about. Now I'll go back to the SSH session that I'd started in the first video. As you can see, I'm in the QEWD apps directory, which is where in the first video I cloned the QEWD-JSdb GitHub repository. Let's just take a quick look at its contents. You'll see in a minute why we took this quick look. For now, let's continue. Now the QEWD platform that I'm using is running in a Docker container. QEWD is a Node.js framework, but all that was actually installed on my Raspberry Pi in the first video was Docker. Everything else you've seen at work is happening inside the QEWD Docker container. So as you can see, I don't actually have Node.js installed on my Raspberry Pi. The Node.js environment is all within the QEWD Docker container. So how can I use the Node.js REPL? The answer is I need to somehow get inside the QEWD container. So how do I do that? Well, Docker provides a command called exec that allows you to shell into a container. We can use that command to get into the QEWD container. First we need to know the container's name. Docker ps will show us that. So you can see here that our container is named JSDB. And we can shell into it using this command. Okay, so now we're inside the QEWD Docker container's bash shell. I want to switch to a folder named mapped. Now why did I go to this directory? Well, remember when we took a look at the QEWD-JSdb directory a minute ago? Let's now take a look at the contents of our container's mapped directory. And you'll see that these are the same files and subdirectories. What's going on is that when the QEWD container was started up, the docker run command mapped the Raspberry Pi host's QEWD-JSdb directory to this directory named mapped within the container. Everything we need for QEWD-JSdb is therefore in this directory named mapped. In fact, we can look at the start command that we used to start the QEWD container. You can see the docker run command that I was referring to. And you can see the volume mapping here of the host's QEWD-JSdb directory. Right, we're now ready to start the Node REPL, and we do that by simply typing the node command. Next, we load the JSDB shell module. This is a module that's supplied with QEWD-JSdb, and you can see it here in the mapped directory. We use the require function to load it. Loading this module has made two key things happen. First, it's connected our Node.js REPL process to the actual database that's used by QEWD-JSdb. In the case of this Dockerized version of QEWD, it's the open source YottaDB database, which is pre-installed in the container. The connection to the database is actually an in-process connection, not over a network, and that makes it extremely fast. Secondly, the JSDB shell module has loaded the QEWD-JSdb abstractions, so that when we access the YottaDB database, as far as we're concerned, we're dealing with JavaScript objects that just happen to be stored on disk in the YottaDB database. Now we can start playing around with QEWD-JSdb's database and begin to see some of those abstractions at work. In this video, I'll show how a JavaScript object can be mapped between in-memory and on disk in QEWD-JSdb. I need a reasonably large and complex object to demonstrate that with, and rather than waste time laboriously building one here and now, let's use one that's automatically available. The first thing we need to do is to instantiate what's known in QEWD-JSdb parlance as a document node object, and we do that like this. I'll explain document node objects in detail in another video, but essentially what this has done is to tell QEWD-JSdb what persistent document to use in the YottaDB database. In this case, it's a document named config. The use method has returned a document node object that we've named config. Okay, at this point I'm going to bring both the browser and the SSH terminal window into view, so you can simultaneously watch the viewer application when I enter this command. Okay, so instantly, as if by magic, you see that stuff has happened in the viewer application. Let me explain what's going on. What we did was to invoke the setDocument method of our document node object that's named config. The setDocument method maps JSON content to corresponding hierarchical storage in our YottaDB database. We use the process.config object as the JSON to be stored. And if you look in this left-hand panel of the viewer application, you can see how that JSON has been mapped into YottaDB's hierarchical storage. This is known as global storage. Once again, I'll explain global storage in detail in another video, but in summary what you see is that it's storing the data in a persistent document named config. That was because it was the argument that we used in the JSDB use command. And each of the keys in the JSON document have been used as what are called subscripts in this global storage. And the value of each leaf node in the JSON document is mapped to the value of each global storage node. So if we look again at the process.config object that we used as the JSON source, you can see how, for example, this item, variables, arm float ABI, has been mapped to YottaDB's global storage. And here's the value, hard. You'll notice one thing, it's not mapped any empty arrays in the target default section of the JSON. If they'd have contained elements, then they would have been mapped. So the setDocument method saves JSON to the database. How do we get it back again? Well, we can recover the entire JSON object again by using the document node object's getDocument method. So I could do this. And let's take a look at my config. There we are. The JSON has been fetched from on-disk storage into my in-memory object called myConfig. Now if we look at the right-hand panel of the viewer application, you'll see that it's already showing you what the stored document will be retrieved as in terms of JSON, i.e. using the getDocument method. So this viewer application is a very handy tool for seeing in real time the effects of any QEWD-JSdb APIs that we invoke, at least the ones that affect the physical global storage in the YottaDB database. And handily, it will also display what it represents in terms of JSON. You might be wondering how this viewer application works. It's actually a pretty simple QEWD WebSocket-based browser application that's listening for the events emitted by the QEWD-JSdb primitive methods that set and delete data in the YottaDB database. Those events are then triggering a listing of the corresponding global storage represented by the document node object, along with a getDocument listing of that document node object in the right-hand panel. So how can you be sure that this has actually stored this data in a database? Let's prove that this isn't just smoke and mirrors. So let's exit the REPL. To do that I type 2 Ctrl+Cs, and then I'll start a new REPL process. I'll load the JSDB shell module as before, instantiate that document node object again, and then run its getDocument method. And there we are, it's retrieved the JSON from the YottaDB database for us into our new REPL process. Okay, so what if I was to stop the QEWD container completely and restart it? If it's using a database, then it should be able to persist the data between container restarts, right? Well, let's try it out. I'll exit the REPL again, and then exit the container's shell, which returns me to my Raspberry Pi host shell, and then I'll stop the container. To do that, I use /stop and restart it again. So now I'll shell into it, switch to the map directory, start the REPL, load the JSDB shell, instantiate the document node object, sorry about that error, and run its getDocument method. And now we'll view it. And oh, there's nothing there. So what's gone wrong? Well, actually this was entirely to be expected because of how I'd started the container in the first place. Let's list the start command. We can see that although it maps the QEWD-JSdb volume, it's not doing anything to map the actual database files that are used internally by the YottaDB database that's included in the Docker container. What's happening then is that YottaDB is maintaining the database files internally within the container, which is fine until I restart the container. At that point, those internal database files are lost and new ones are created. Now, if we look in this map directory, you'll see that there's another file in there, start_p. And if we list that one and look at its docker run command, you'll see an additional volume mapping, which is mapping the YottaDB database files to a directory on the host system. And during the installation process, empty pre-initialized YottaDB database files were installed in that mapped host directory. So let's start again. I'll exit from this container and shut it down. And while we're here, let me show you that YottaDB directory containing the pre-installed database files. So let's start up the container in persistent mode using start_p. Then go through all the steps as before. We'll shell into the container. At this point, we'll need to refresh the viewer application to make sure it reconnects to our new queued instance. Okay, we switch to mapped, start the REPL, load the JSDB shell, instantiate the document node object, and we'll save the process.config JSON. And you can see from the viewer application that it's been stored in the YottaDB database. So now let's see if it survives a container restart. I'll exit the REPL and container shell and shut down the container, and then restart it again, most importantly making sure that I use the start_p command again. Okay, now let's go through the steps as before. Shell into the container, switch to mapped, start the REPL, load the JSDB shell, instantiate the document node object, and okay, now let's try fetching its contents. And let's take a look. And success! There it is. It's definitely persistently saving our JSON into the YottaDB database. Okay, that's hopefully given you a bit of a taster of what QEWD-JSdb is about, at least in terms of how it can store and retrieve JavaScript objects. But there's a lot more to QEWD-JSdb than that, but we'll need to save that for later videos. In the meantime, why not try out QEWD-JSdb in the REPL for yourself with some other JSON and familiarize yourself with the way it maps to and from YottaDB's hierarchical global storage. So that's it for now. Thanks for watching, and make sure you check out my later videos that will further explore QEWD-JSdb and explain what it's doing and how it all works.